Today we will learn the XYR method for evaluating trig ratios. So if we have theta, which is an angle sketched in standard position, then the point where the terminal side intersects the circle, if we go back x, down y, that's our x and our y coordinate here. And r would simply be the radius of the circle. Okay, and notice that the radius of the circle is the hypotenuse of that triangle. So here you need to memorize these values. And really, if you memorize sine is y over r, and I usually remember that cosine is x over r, that's really all I remember. Okay, and now I just know that tangent is the numerator over the numerator. So that's y over x. And then to do the other three trig ratios, all you have to do is the reciprocals. Now, let's see if you understood any of that. Find the 6 trig ratios for theta through the point -3, +4. So starting at the origin, if we go back 3 and up 4, the point on the circle, again, is -3, 4. And the radius can be found by finding the hypotenuse of this right triangle. When we're looking at a radius, that's always going to be a positive value. We went back 3, up 4, and we could use Pythagorean's theorem to say 3 squared plus 4 squared equals r squared. And we would get 9 and 16, which is 15, and 25, excuse me, and take the square root, and we'll see r is 5. Or you could just know that triple, 3, 4, 5 go together. At this point, we have an x, a y, and an r. And so I'm going to scroll back up. We see sine is y over r, and hopefully we'll start to memorize those. So sine is y over r for our angle theta. So y is 4 and r is 5. So that's the answer. And for cosine, x over r. And we have -3 is our x and r is 5. For tangent, y over x. So we have 4 over -3, which is -3/4. And now we can do our reciprocals. Cosecant is just the reciprocal, so that'll be 5/4. The reciprocal of cosine is secant, so that's -5/3. And my reciprocal here, they're reciprocals of each other. I get a -3/4. So those are our 6 trig ratios. Once you figure out your x, y, and r, the rest follows pretty quickly. Now, the unit circle is going to be so important in trig. So I'd like to introduce you to it today. On the unit circle, it just means that the radius is 1. And obviously, it's 1 in all directions. So the coordinate of this point would be over 1, up 0. And you can go 1 in any direction, and this can be very helpful in solving problems. And I'm going to show you that right now. Let's evaluate the 6 trig functions for theta equals 180 degrees. We're going to use the unit circle to help us do this. Radius 1 at 180 degrees. 180 degrees is right here. And the coordinate of this point, starting at the origin always, I'm going to go back 1. So x is -1. And I'm not going up anything. So this is my x, this is my y. And remember, I used the unit circle, so the radius is 1. So if I want to know the 6 trig functions, I do just like I did for the last problem. That's going to be y over r, so that's 0 over 1. Y is 0, which just equals 0. The cosine of 180 is x over r. So that's negative 1 over 1, which is negative 1. And then we have the tangent of 180, which is y over x. My y coordinate is 0. My x coordinate is negative 1. That just equals 0. Now the reciprocals might get a little tricky. So we have the cosecant of 180 degrees. Flip the fraction, and something bad happens. Remember, thou shalt not divide by 0. So we say this is undefined. When we do our reciprocal here, we get 1 over negative 1, which is just negative 1. And our reciprocal here, for the cotangent of 180, we get negative 1 over 0, which again is undefined. So we're gotta be careful about dividing by 0. And this happens sometimes. Later when we do the graphs, you'll see that those will be asymptotes. Now, I'd like for you to know that we really did not have to use the unit circle to evaluate these. I could have said, make the radius 2. If I would have gone back 2 units, this point would have been negative 2, 0, and the radius would have been 2. Not a big deal. And for example, when I would have done, let's say, the cosine of 180, x over r, x would have been negative 2, and r would have been 2, and that still would have reduced to negative 1, which is the same answer. But notice, if we're not in the unit circle, then we have the hassle of reducing. So save yourself the hassle, just do it in the unit circle. Now, let's see what a reference angle is. That's the acute angle that is between the terminal side and the x-axis. So if you have any generic theta, let's say we have theta over here, then the reference angle would be the angle between the x-axis. Notice we have a positive x and a negative x-axis, but it's all the x-axis. You want to go to the closest side. So this would be considered your reference angle right here. And we use that because now we can make a right triangle. If we tried to make a triangle here, it wouldn't be right. It wouldn't be right. Anyway, so we're looking for a right triangle. So that's why we do that. Okay, let's see if you understand that concept of a reference angle for each of these. For 210 degrees, let's sketch that. 210, let's see, that's past 80, past 180, I mean. But the difference here is our reference angle. Right here, this is the reference angle. You just want to be able to make that little right angle. So our new angle would be 30 degrees. So you're really just saying, how far is it from the x-axis? Never go to the y-axis. No, thank you. So now let's do it for 300 degrees. 300, let's see, that's ooh. So the x-axis over here is 360 and 300 is 60 degrees away. So my reference angle is just 60 degrees. And that's going to allow me later to make a nice little right triangle with a 60-degree reference. So hopefully you're starting to see why that might become useful. Let's evaluate the cosine of 150. The first thing I'm going to do is find a reference angle so that I can draw a right triangle. So 150 is over here. That has a reference of 30, right? If that's 150 and the x-axis is 180. And now I can draw a nice little right triangle with a 30, 60, 90. Okay, so what I want to do is figure out an x, y, and r. And I didn't give you a point. I didn't give you a radius. I didn't give you anything. And the reason is it doesn't matter. You can put any values you want. So you know I'm going to do 1, 2, radical 3. The hypotenuse is always your 2. Opposite of the 30 is always your short leg. Okay? And guess what? Now I have a x, y, and r. Alrighty. From the origin, I went back radical 3. And I went up 1. So there it is. That's my x, that's my y, and that's my r. Pretty cool. Later, we're going to find out that the x is really adjacent, the y is really opposite, and the r is really the hypotenuse. So this is really no different than SOHCAHTOA, but we call this the XYR method. So for cosine, we know that the cosine of an angle is x over r. So x is negative radical 3 and r is 2. Final answer. Negative radical 3 over 2. And remember, you can write the negative sign directly in front of the fraction bar, or you can put it in the numerator or the denominator, just not both. Example 5. Let's evaluate the cosecant of 315 degrees. So we're going to repeat the process that we did in the last problem. Sketch the angle first. 315 is over here somewhere. That's 45 degrees away from the x-axis. And you can draw the circle or you can just imagine it. So 45, 45, 90, 1, 1, radical 2. My coordinate point here, my x, I went over 1. And then I went down. So my y is negative. So now my r is radical 2. I just need to remember this is the reciprocal of sine. Sine is y over r, so this is r over y. The radius is radical 2, and y is negative 1. Final answer, negative radical 2. We're going to later find out that everything is positive in the first quadrant, but as we go into the second, third, and fourth quadrant, some of the trig functions are negative. Alrighty, last example. Find the coordinate on the unit circle. Ooh, unit circle, radius 1 at 240. I didn't ask you to evaluate it this time. I just said, let's find the coordinate, which is our x and y. So what we're going to do is we're going to first sketch 240. Wow. Okay, this is 180 and this is 270, which I really should not concern myself about that 270 because although it's closer to that y-axis, you only make your reference touch the x-axis. Now, I said, what is the coordinate on the unit circle. So there's something quick we got to do here. This is a 30, 60, 90. So 1, 2, radical 3. Remember, the hypotenuse is always your 2. Across from the 30 is your 1. So even if it's not drawn to scale, make sure you have the right values. Across from the 60 is the radical 3. So I asked for this xy, but I didn't ask for it with radius 2. I asked for it with radius equal to 1. How can I turn this radius of 2 into a 1? Well, I can divide by 2. That'll give me a 1. But if you divide one side by 2, you got to divide all the sides by 2. So now the coordinate of this point is back 1/2, which makes it negative, and down radical 3 over 2. In the next lesson, we're going to see why